Very pleasant good morning to all. Welcome to day 2 of IIT Bombay CSE Research Symposium. We hope you all enjoyed the sessions on day 1. We have some really interesting talks planned for you on day 2 as well. One trend that I would like to reinforce is that please make these talks as high-yielding as possible by making them interactive. So we encourage you all to ask questions. And please remember that there are no bad questions, so please feel free to reach out to our speakers and ask questions. They'll be happy and delighted to answer you all. And we really appreciate your enthusiasm and participation and cooperation from day 1. So let's start day 2 with the same amount of energy. And with this, I would like to introduce our first speaker for today. It's Professor Rijurekha. She completed her PhD from IIT Bombay in 2014. She was under the guidance of Professor Bhaskar and Raman. She was a recipient of the esteemed Microsoft Research India Fellowship. She was also awarded the ACM India Doctoral Dissertation Award. She was a postdoctoral researcher at the Max Planck University. She was also the recipient of Google India AI/ML Research Award 2018. She has a significant number of publications in the top forum, which are heavily cited. And currently, she is a professor in the CSE department at IIT Delhi. Her research interests lie in building distributed, networked, and privacy-aware systems focused on the boundary of information technology and society. So without further ado, please join me in welcoming Professor Rijurekha with a big round of applause. I mostly mentioned her academic achievements, but apart from that, I would also like to mention that she has a very warm and encouraging personality. She is very approachable. We had a chance of interacting with her at the ACM India annual event, which was in Bhopal this year. So she was very encouraging and welcoming there. Please welcome her once again.
Thanks. I'll start off, and this talk is on sensing for urban sustainability, and I write some sort of a disclaimer here that where are we stuck. So the first slide I show, I generally don't show, but the question I asked most is why did you do a PhD in computer science? What are we even teaching in a computer science department in IIT Delhi? Because what is sensing for urban sustainability, in what way is it related to computer science, right? Because urban sustainability, these are civil engineering issues, transportation issues, right? And sensing is also electronics or maybe MEMS or something like that. And we generally tend to think in these buckets, right? There are theoretical subjects like algorithms or data structures or discrete maths. And coming from an UG background, most of you, you might also think that these are the courses which we have taken, right? And we learn in those silos that these are systems courses, these are theory courses, and we tend to think like that where does, which bucket among these does she belong? Right? And it's not only for UG students, it's even my departmental colleagues. They will ask that, Riju, what in computer science do you do, right? And why are you in the department? That's the question. And yesterday's talks, again, reinforced our buckets, right? We had very clean talks. We had an algorithm talk in the morning, followed by formal methods. And then we had AI and machine learning talk, which had to do with a lot of people stuff, like at a front end on a mobile device, but still it was AI and machine learning is also still very computer science, right? So let's see, and I'll say that the most important research question in my research is how to connect my work to computer science. Okay, so we'll see that. So a few people made things starting for me. This was Professor Hari Balakrishnan's group from MIT CSE, and he wrote this ACM census paper in 2006, right? So I started PhD here in 2010, and in 2006, 4 years before that, he wrote a paper called CARTAIL, a distributed mobile sensor computing system. Okay, this was the title, and the idea now it seems very obvious that he said there will be some cloud server and cars will be moving around in the city, and these cars will have GPS and they will send their locations to this server. And then on the server, they would do a lot of computations, a lot of analysis, and they will show these kind of travel times and others in green, red and other colors. Okay, so this was 2006, and Hari's group in MIT was one of the people who was talking about this. In India, Venkat Padmanabhan, he came back from the US, he started a group at Microsoft Research India. It's a very strong group, and he wrote a paper in again Census 2008 called Naricell, which said rich monitoring of road and traffic conditions using mobile smartphones. So it said that mobiles have, and we can add accelerometer, gyroscope, compass, many sensors which have these kind of signatures. It's making a lot of noise. Right. So it has a lot of sensors. So using those sensor values, you can know whether the road has a pothole or a bump or how is the road quality, and this you can do using many vehicles on the roads. Okay. So these were kind of idea papers, and I joined Bhaskar here in 2009. I was a MTech and then I converted to a PhD. And Bhaskar said that for Indian roads, right, which look very different from the US roads or from any other roads, because we have non-laned driving, can we do something here? Okay, so that was the question, and I knew nothing about anything, right? After UG, I have also missed all my classes, bunked them. I've come here for a PhD, so I don't know whether this is a good computer science problem, this is a bad, what is it, right? I am just starting out. So I said, okay, and we had some crazy ideas, and I'll explain only one here. We said that, okay, it was not the age of deep learning yet. Computer vision and those things were very expensive and not very accurate. And in Indian traffic, it was even more harder, right? Because our traffic don't follow lanes and they are just all over the place. So what I and Bhaskar tried to do was, I will keep a wireless sensor on one side of the road. I'll keep a wireless receiver on the other side, and we will just send some packets, okay? And based on how much traffic is there on the road, right? Because traffics are this heavy metallic object or the vehicles, and they diffract and refract the network packets. So based on the signal strength and the packet drop rate, we could very well estimate that what was the traffic volume, right? So on the right hand side, I show a plot which was taken on Adi Shankaracharya Marg, just outside in the campus. Some of you might have been there, where I plot the signal strength on the x-axis and the cumulative probability of seeing that on the y-axis. And each of this curve is a 5-minute plot, right? I am standing on the road. I am standing there from 5:30 p.m. in the afternoon to 7 p.m. in the afternoon, right? So 5:30 p.m. when I just start off, you see this black curves, which is very good RSSI. So I am receiving packets at very good strength. And then around 6:20 p.m. as the traffic starts getting heavier, you see the distribution shift to the middle, and then the distribution shifts completely to the red curves at the right when it is heavy office hour traffic. Okay. So just with 200 rupees wireless radios, no cameras, nothing, and sending a few packets, I am able to estimate that whether congestion is building up on the road or not. Okay. So this was one of such ideas, and generally when we have one of such these sort of ideas, we have to build a proof of concept, right? So this is my workflow, that what do I do day to day, that first I have to think of the problem, some idea which might work, some intuitive idea, and then I have to build some proof of concept, and the proof of concept looks typically like a set of graphs like this, right? Is my intuition correct or not? I just try to work it out, and then I have to prototype the solution, right? Whatever, I mean, build some PCBs, get some components, maybe build some hardware. If it can be done with a smartphone, well, write an app for it, whatever be it, right? I have to prototype the solution. And then there is a lot of testing, like the picture there, and then I deploy it on the road. Again, I took a picture from my PhD days. This is again Adi Shankaracharya Marg. And I also have to take a lot of ground truth, right? So what my sensors are seeing, wireless sensors, will a human or a camera see the same thing or not, right? So, so this is kind of my sensor pairs, and we built a queue of them, right? And the queue could say that how far has the queue gone, right? And you can go up to a kilometer or 2 kilometers even, starting from the intersection, to know in real time how long the queues are. Okay? So this is, and again we go back and we do things and stuff like that. Okay? So at the end of my PhD, so this was when you look at a PhD thesis, right? How does it look like? It has typically 2 to 3 chapters, right? So this is how we divide up our work, that it will take us 4 years, and depending on the field of your research, the number of papers in each chapter will vary, right? When Ashish does his work, a single top tier paper is very, very hard, right? Because he is working on a problem which is open for 20 years. You can understand how hard it will be to solve it, right? So over 5 or 6 years, if he writes a single paper, it is fine, right? It depends on the hardness of the problem. I was not working on a very hard problem, right? So I had some papers like that in my chapter 1, some in chapter 2, and then I also did a couple of internships at Microsoft Research, and I had some papers from that, right? So this list was at the end of 5 years of having ideas, building system, and trying things out. Okay? So I wanted to take a point of conferences also here, that when a researcher like me is starting off on an area which is not a computer science so-called old field, right? We are very grateful for some other people to have started some conferences which are okayly rated, okay? Because the top systems conferences like SOSP or OSDI or even SIGCOMM, which is a networking conference, will not take these papers. They will say that we want core operating system paper or core computer architecture paper or networking paper. This is nothing, right? You are mixing some wireless network, you are mixing something, you are trying to solve a real world problem, right? So why should I accept your paper? And valid point, right? So there, so Mobisys, Census, IPS and Mobicom were the venues, and if you look at it, they are relatively new, right? Most of them started around 2003 and 2004. So these are just 20-year-old conferences, and when you look at Kuldeep's talk yesterday, he started in Greece, right? So that's such a long legacy and history, and even Ashish, I think the theory conferences are much, much older, right? So this is a very immature or a growing kind of a field academically, I would say. But I'm at least grateful that there are a certain set of conferences which these Hari Balakrishnan, Victor Bal, they started out so that at least as a PhD student, I could send my paper somewhere, right? So because in PhD that is very important to get publications. On the other hand, if we forget about academic impact, I think we all see where Cartel has gone now, right? We cannot imagine our life without looking at Google Maps, right? How long will it take to reach from the airport to here, or when will Swiggy arrive with your food? That's a given in our life now, right? And I mean, it's like that is one beautiful thing about doing this kind of work, that you can actually see it going somewhere. Okay, so this is we do it, and even for Naricell and those things, there is a huge thing of driving safety. Insurance companies want to rate drivers, that how safe their driving is. So in vehicle sensing, I'm just showing a few examples here. That ZenDrive is a company, that mobile app is from Hari Balakrishnan's group again. And this bottom one is very interesting. In India, at least in Delhi, there are these driving tests automated, right? And you take the test and it tells you that you have to do a reverse 8, you have to do those things. And Venkat Padmanabhan's group at MSR built this solution and deployed it, okay? So all the licenses we are giving out have these systems built into them. Okay, so it's paper is one thing, and then there is this this world that we are working on. And this is this because of these kind of impact, these people, Venkat here from MSR, they also get this test of time award, that after 10 to 12 years, how much societal impact has the work got, right? In addition to citations and other academic impact, right? So, and we know that cars are so highly instrumented now that we don't even need to drive them anymore, right? I mean, you have all heard about self-driving cars and everything, that they will just drive themselves, right? And that's the reality, right? Now that things are great, right? I mean, we started with a few GPS units as a MIT project, and now we are here where cars are just on the road driving themselves. Right? It's a great story, right? I mean, it's tremendous. So this is where are we in 2023? It's a huge success story. And actually we are, I mean, I came from airport to IIT Bombay on Friday night, but I was still stuck there. Okay, so it took me 1.5 hours to reach from the airport to my guest house, which should have taken me 20 minutes. 30 minutes max, not 1.5 hours. Okay. So these two pictures don't go with each other, right? One way we are saying that cars are intelligent, right? They will just, we put a car on the road and it will drive itself. And on the other hand, I am sitting there on the road for 1.5 hours. Not only me, the ambulances, everyone, right? Only if a minister's convoy comes, we will create a green corridor. We will take even more time because that corridor will pass, right? So I mean, there is something which is a huge gap between these two places, right? And then again, my department will ask me the question that we have to improve public transport, we have to reduce dependency on private vehicles, right? We have to build more roads and flyovers to create route alternatives. We have to audit how budgets are being allotted, right, to different states. Why Delhi has so many roads and so many flyovers? Why doesn't Maharashtra have it? Right? Why doesn't West Bengal have it? Is it some political thing? Right? I mean, they will ask these questions, and then they will ask me this question, where is computer science in all this? We are back to square one, that we say that this is not our problem. This road looking like this is not a computer science problem. Okay? So that's again, as I'm saying, that's the main research challenge that I face, that how do I connect it, right? So the first thing, let's look at it one by one. So the first constraint, yeah, we say that, okay, budget is a problem, right? Whenever I talk to government agencies, everywhere, right? They say building more roads, building flyovers, even putting cameras on the road, whatever it is, everything needs money, right? And we don't have money. So they say that we are under extreme budget constraints, okay, and there is some place, right, where we could generate a lot of money for the Delhi police or the Delhi traffic organization, which is through giving challans. Okay. Challans means that it's the only money making part of the Delhi traffic police, where they say that you overspeed, you do something, and like we never follow rules, right? So giving challan is the best possible business opportunity, right, for the government, right? So I mean, it's the like was an untapped market, and they just say, yeah, madam, aap ye kar dijiye, so it's very good, right? And this you can use it for, once you have the cameras on the road with their permission, and it is generating its own money, right? You can do a lot more with those cameras in addition to giving challans, right? I mean, the cameras are there. I mean, already the sensors are put up. It's good. So now you can just see the traffic density, that the blue curve is again similar to what I had in my PhD. Now each of those lines is a signal change, the green signal and the red signal, right? The green signal and the red signal. This is how things are changing, and you can see that the blue line, the density is going up, and then when the signal turns green at the vertical line, it starts coming down, right? So you can measure these densities, and you can also look far, right? So you can maybe control the signal in some intelligent ways. Okay, so I'll show how. And of course, as a professor, it's hard for me to work on the ground, get cameras from China and do things. So there are very helpful field partners. Okay? So Vehant and Abmatika, they are both companies. Vehant works in Noida and other places, and Abmatika works along Delhi, the ring road. We have around 20 cameras along ring road in Delhi, and they don't have the research capability. They are startups, but they can procure stuff, they can put things up, right? The software we can build in IIT. And again, in terms of competence, right, I am not trained in computer vision. So I also need a vision collaborator to work with me, and Chetan is that collaborator. But the question which I ask, right, and or Chetan asks me is, Riju, I know computer vision, right, and just like Prateek was telling you yesterday, that all computer vision models are now 152 layers resonets, right, and they take MBs, and you need to run them on the cloud, right. And now from the road, we don't have broadband connectivity of fiber optic to the server, right? We don't have it. So Chetan says, can you run my heavy algorithms some ways on the road, right? So that is again a embedded system and edge computing, IoT, whatever we call it, right? The name changes from decade to decade. But it's entirely like at the place we do some processing, right? And can we do that? And there is an additional challenge here that in Delhi or most cities in India, the ambient temperature goes to 45 degrees Celsius, okay? And if you are running an embedded GPU from NVIDIA at 45 degrees Celsius, your board will get burnt in 1 hour, okay? So this is not an AC data center environment where I am putting my devices, okay? So fine, so there are works, and this from Pratik's talk yesterday you already saw. So this is a page, course page I am putting up here, and the slides and materials are there. So some of you are students, you can take a look at it, that how do we take something heavy and can make it run on a small platform, okay? It is deep learning now in this part of the talk. It might become cryptography at some other point. It might become something else at other point. I don't care. I am given a program, it does something, but now it has a lot of computations which cannot meet the latency, accuracy, energy, thermal constraints, okay? So a set of constraints. So very similar to what Pratik was talking about yesterday, that you are doing some things on the mobile device, and he was focusing on these, maybe the last 2 points he didn't give too much on the technique, but there are, for neural network there are compression techniques, right? You quantize the network to less number of precision, or you can actually learn smaller network, right? It does the same job. There was too much redundancy earlier, so you can do that. And sometimes I have to also do some systems and also hardware architecture part. So I don't design new chips, but if someone says there is an FPGA, there is a GPU, there is a TPU, NPU, whatever PUs, right? The hardware companies are coming up with accelerators like this, which are not CPUs, right? Which are not what we typically have. And how do they behave for this particular problem? I might have to look at this newer hardware architectures, right, and try to interface them with my work. And on systems, of course, pipelining, caching, whatever principles we have followed in systems research, they should also go in, right, to balance these trade-offs. So the other thing is this, at least the machine learning workloads, the ecosystem has become very, very complex, right, because every company wants to have some product in this space, right, and there are too much choices. So if you look at the last line, that these are the hardware choices, then the operating system choices, then someone was asking yesterday about the, whether it's PyTorch or TensorFlow or MXNet or what is the framework, right. So TF-Lite, and we have so many of them, and then compilers and models and data sets and applications, right. So even good measurement studies of what are the faults of each of these things, right, so we found out that actually NVIDIA's TensorRT, it is somewhere there under the inference engines. So though NVIDIA gives it, it performs much more poorly on NVIDIA's GPUs than an open source framework like AutoTVM or something, and in fact NVIDIA TensorRT even changes your results. So it doesn't do a check on precision, that the same cat image you give it, it says it's a cat, you recompile the program, you run it again, it says it's a dog. So it doesn't check for this change in accuracy once you do these precision changes, okay. So the point of showing this sort of a diagram is even measurement studies are sometimes very useful, benchmarking studies, that how do things look in this complex ecosystem of hardware and software, okay. So as a professor also I guide PhD students, and they have their own research career, right, and I have to write papers, and now you see that my papers are not in Mobises or Senses, the venues I showed you for my PhD work, right, because Mobises or Senses have moved to self-driving cars, and I am still stuck at Worley, right, or somewhere, right. So hopefully I will catch up sometime, but thankfully there are not like a dearth of computer science venues. And if I am working with FPGAs, I can send to the top tier FPGA conferences, FPT and FPL, and I can send to even a machine learning conference like NeurIPS, because there I was compressing a network which had too many parameters which were redundant, okay. So it doesn't matter that, it's like I have to look at what the problem is, what technique I am using to solve it, and then say that which which venue will appreciate this work, right? So for me it works like that, because it's not like it's a given that if I send it somewhere, they will say, yeah, good, well done, okay? So this is, finding a venue is also sometimes a challenge. So this part where I was talking about this constraint, and then I wanted also show some positive things, right? I mean, are things like, is there some problem where we are making better progress, right, than traffic maybe? So this is I'm asking that when I went for a postdoc at Max Planck for 5 years, in Germany we didn't have a paucity of funds, right? I mean, it says you can do it, you can do research, you are great researchers, so well and good. And the two advantages which I saw of that was I could scale work from urban to global scale. Okay, even I mean, if you see it's not important to know what this problem is. It's not related to traffic or something. It's related to Facebook's free basics. Okay, so it was I was working on that. But on the x-axis of this plot, you can see we had countries from Asia, Africa, and South America. Okay, so I could send apps to collaborators there or workers there whom I could pay with money, and it was a global experiment, okay, which I presented at SIGCOMM and these places because I could scale, right? There was no constraint on what I could do. And the other thing which it brings out is you can define new research problems now, okay, because you are not constrained there. Will this even work? Will this even work in time, low latency? Will it not burn out in heating, right? So there people were worried about security of the platform. Are there any privacy concerns of the data, right? In India, I have been putting sensors for maybe 15 years now. Nobody asked me the question that where are you sending this data? Who can look at this camera data? The traffic police, nobody is concerned that who is taking our picture from which CCTV camera, where is this data stored, who is reading it, right? Who is looking at it, who has our data, right? I am not asked those questions in India, right? When I went to Germany, at every point they were asking, blur face, blur this, do that, do this. Privacy was important, right? Because they have solved the other problems, a lot of them. So this was a good lesson, and I wanted to at least try somewhere where I didn't have so much constraint, okay? So for example, if there is an urban sustainability problem where budget is not a problem, I am getting money, and I don't need a lot of network bandwidth, because for traffic, the computer vision, it needs video, right? Without working with video, and video needs a lot of bandwidth, real-time video, right? So is there some problem where network is not a issue, and even thermal safety is not maybe a pressing problem, okay? So this is somehow, it is a national agenda problem, air pollution, right? Maybe because Delhi is the worst affected, and it's the face of India to the world, right? Anyone comes there and it has created a very bad impression, thankfully, right? Even our traffic situation should create that kind of an uproar, right, in media and everywhere. It hasn't, right? I never see traffic jam or why do we have, I don't see dharnas in Jantar Mantar for that, right? I mean, there is no conversation at all. So, but air pollution, somehow there is a national NCAP program, right? I mean, it's a huge thing, at least in Delhi and even in other cities, where the government is under some pressure, right, both national and international, to do something about it, okay? So there is no paucity of funds, and like I have funds from this Environmental Defense Funds, which is a US organization. The DST SERB given me 1 crore rupees on the first year of my joining IIT Delhi. I knew nothing, right? New faculty, it comes and gives me 1 crore rupees and do something about air pollution, okay? So it has huge funds. And funnily, the sensing mechanism is the same as I showed you in the first slide of my PhD. Here also, the sensor, it has a laser beam. There are particulate matters now. It's not big vehicles, right? And it's PM 2.5 and PM 10, and the laser beam now get diffracted or refracted, right? And the change in angle tells that, so you see that in science, that's a good part, that the basic principle remains so same, although the form factor, there was Wi-Fi and Zigbee there, now it is laser, but at least the mechanism is same. I understand this sensor, okay? So this is good. And now I have a lot of money, so I can just build a lot of units, right, to do sensing, right, to do air pollution sensing now, and I can put it up also everywhere, right? Not I don't want to put it up everywhere because then I am causing a more sustainability problem. I don't want electronics at every place, right? But at least what I did was, these are pictures from Kolkata buses, and I also did this in Delhi buses, that you put sensors in buses, right? And the buses are moving around all across the city. They are idle only maybe 4 hours in a given day, right? And rest of the time they are just moving, and you have GPS sensor there. You have axle gyro to know whether the bus is vibrating too much, right? So you can filter out some of the noisy values, right? And you can get a lot of data like that. And you can download this data set because it's with DST public funds, and you can work on it. So this is an average Delhi air pollution in November. In December, I have more maps like this, where it says that the bus collected values, what does it show, right? And this is spatio-temporal. You know there is an industry here, you know there is traffic here, you know there is this thing here, right? It's actually moving through the locality. So you do a very hyper-local mapping of air pollution here. It's not like one sensor is there and the other sensor is 60 kilometers away, and you don't even know what happened in those 60 kilometers, what caused it, right? This is very fine grained data, not very low cost, right? Every unit is a embedded unit, which I show in that picture. And once we have data at this scale, my machine learning friends in the department are very happy. So I have some allies in the department, right? It's good to have these allies that they say that, for example, there is Sayan Ranu, a very good friend, who says, okay, now you are giving me so much air pollution data, I will try out very complicated interpolation, forecasting, and all sorts of machine learning algorithms on this data set, okay? And we have other data sets from Canada, and what we see is, this is left side is Delhi, that whatever complicated algorithm using graph neural networks, Gaussian processes are the two NG, NSGP rows. So they have a high RMSE of 66 or 46 or 42, whereas in Canada the pollution is so small and the variance in pollution is also so small that the values are really, really low. Okay? So this means that the machine learning community has to come up with either better models to do this prediction and forecasting, and this is a data set that they can use to test out newer ML models. Okay? So I am adding some computer science value there. Another thing which is coming up multiple times, that maybe pollution is affected by too many factors, okay? And to even understand this, I will use these two plots. So it says that the top plot is for November 14, 2019, and the bottom is November 18, 2019, okay? So Delhi government came up with this odd even policy in that window. So November 14, there was odd even policy where they said only odd numbered cars will go out and even numbered cars will not go out. They are trying to reduce the traffic on the road, right, to see effect on air pollution. November 18, the effect was not there, the policy was not there, right. And I am plotting average PM 2.5 with my sensors. Funnily, the PM 2.5 without the policy is much, much lower. So this was a disastrous curve for Kejriwal, because he has brought in a policy which everyone is angry about. They cannot go to school, they cannot go to college, they cannot bring out their cars, everyone is fighting, right. And now I am plotting graphs like this, which says that, okay, it actually had a reverse effect, right. What kind of stupid situation is that? And before going there, I also wanted to say that the same graphs also show some relation with traffic, some other relation. Actually, the first plots up to 25 were in IIT campus, and the last 3 bars are from Lajpat Nagar and other 2 intersections. So if you see, even though all the bars have come down, the traffic intersection bars are significantly higher, going up to 600 and here up to 100 compared to the campus sensors. Okay. So if I am in campus, IIT campus, I am green, there is no traffic, no smoke, versus I am at the intersection of the road where there is huge amount of traffic, I actually am seeing a difference, right. So what is going on between the odd even? If there is a difference, if half the cars are gone, it should become lower. And the thing here is wind, okay. So the day on November 14, it is only 2 knots of wind, and on November 18, it is 6 knots of wind. Traffic has reduced, suddenly a lot of wind came on the heavy traffic day and blew away all the pollutants, right. It is not related to traffic at all. There are two factors playing here, one dominated. Similarly here, temperature and traffic, right. So temperature is a very, so in summer we don't have an air pollution problem in Delhi, even though crops are burnt, right. Why? Because the particles expand, they go up in the air, and at the ground level we don't see that density, right. So if you look at air pollution time series at the top graph, it is high at night, and then around 12 noon, 3 p.m. it is at the lowest value in winter, right, because it's very hot. So every day you see this kind of a plot, and at night it again becomes worse. Okay. So now what I am doing is, I have again, as you know, the traffic cameras on the road, right. So I put pollution sensor, I also count the cars on the road, right, and I plot them together. So this is, I titled the slide as heterogeneous data. I am measuring traffic, I am measuring air pollution, I also know the temperature. Okay. And here if you look at this bars here, it says that how many cars are there on the road of different types, and the red curve there is the PM 2.5 value. Okay. So finally you will see that the maximum traffic where there is, the PM is again lowest, right. So if you see the bar height and the PM height, you see that there is a negative correlation almost, that when traffic is at the heaviest, the PM is at the lowest, right. So here again we are seeing that the temperature is the dominating factor, because that time is so hot on the road that the PM is not significant. Okay. So this correlation is a kind of a complex correlation with traffic, that if you see traffic congestion, you might not see heavy PM, because the temperature is high at that point, the wind might be blowing. But at night, when everything is empty, the road is empty, IIT campus is empty, then you will see very heavy pollution value on the road or the houses which are near the road, because then everything will come down from the sky and it will settle at the ground. So it's a delayed correlation effect. Shah and Ranu is very happy with all these things. Okay, he wants to now build this complex Met factor and factor correlation and interpolation and forecasting using these kind of systems. Okay. So I'll go towards the end of the talk now, and so one of the other constraints, right, of doing this kind of work is someone has given you money. Maybe it's a DST research organization, and Google, Microsoft, whoever, right, industry people give lot of money to us, and then sometimes it happens that the government authorities, the only job for them is to give me permission letter. Okay, I say I have brought money, I want to do this, please give me permission, and it is not data privacy kind of permission, right, they don't even ask that. So, and I'll go to this private company part in a bit. So these papers are very, very hard to get, and harder than even a research paper getting accepted. Okay, in my experience, that the first is from the bus organization DIMTS. This is Government of Delhi Transport Department, that is Delhi Pollution DPCC, which is in control of the Pollution Control Committee of Delhi. This is West Bengal Pollution Control Board, right. I mean, these are state organizations which are trying to reduce the air pollution in the city, right. And it's just they might be very busy people. Like, okay, so but the thing is, there is a bottleneck, right, and there is no computer science here other than WhatsApp messages for me, right. That I am showing you a sample that, sir, please send me the letter. I am in Delhi, I need to do this deployment in Kolkata, please send me the letter. This is my email address, right. It's just pleading. It's plain pleading and sitting in front of their offices and going and trying to meet them and call them up, right. So this is the level of letters where I don't even ask for money from them. I say, I build the units, I am just trying to put them up for some sort of a project, right. And I have also tried the other way, right, and I said, okay, government fleets like buses and others are so hard to work with, right. So can private organizations help, right. So when I was doing this pollution work, Ola actually came to me from their side, and they said that we have cabs, we want some good publicity saying Ola is working on the air pollution problem in Delhi, right. So put your sensors in Ola cabs. Very nice, right, I'm very excited. And then we were completely stuck in not being able to add GPS location to the data I collect. So suppose I measure pollution, I don't know where it is collected from. I'll tell you why they are saying this, okay, I'll go to the privacy problem. But I mean, how nonsense is that data that all over Delhi, I cannot even tag them with location and time, right? Then what's the point of sensing something, right? So what they are worried about is what they said, ma'am, you will put these sensors in our cabs, right?
and now Uber will know where my cab is. Okay, so it's a valid problem, right? There is nothing to laugh there. If Uber knows that Ola cabs are near the airport, then they can route their cabs in a certain way, right? It's very strong business concern, right? And as an academic, I cannot say that this is not a problem. Right? It's a huge business concern, and they say that even not the location, the number of cabs, because Ola has some intermittent issues of drivers going on strike. They will switch between Uber and Ola, and they don't even want to show how many cabs they have. So it's a business bad thing for them to know that suddenly the fleet size has gone from 10,000 to 2,000 because 8,000 have gone to Uber, or maybe they are not using Ola. It's bad publicity. I mean, these are all valid concerns, right? I'm not no one to fight with them. And I say that, okay, maybe we do some interpolation, right? Yeah. Huh.
They do have location on, right?
No, that is there, but it is not in that. So this will become public, right? So I am collecting air pollution data. They can use it for their internal purpose, that the driver is seeing how long it will take to reach a passenger. He has a GPS phone on his dashboard. The passenger knows that Uber or Ola is coming in these many minutes. But that is for internal purposes, and you cannot say, you don't have no idea of how many cabs. I mean, they just show some icons, maybe nearby, right? But we don't know. They say 4 minutes away. Is it really 4 minutes away? What kind of noise are they adding? There is a huge amount of noise addition everywhere, which is they are showing us what they choose to show us. Right? Essentially that is that. If I am saying that I will reach somewhere in 15 minutes and then suddenly things are not working out that way, is it because of the lack of samples? Did they did not have enough confidence and still they showed me that number? Where is it? Right? I am just seeing a number. As a consumer of that information, I know nothing. And in fact, that is the point why in air pollution it will never work. Because in air pollution, I have to give the environmental people that what is my confidence in the measured value, right? So I do some sensing, maybe I do some interpolation with some ML method, right? I have to say that I have this much variance in the model, right? This is my confidence value, otherwise how will an environment person use that value, right? So, and if as soon as you plot variance, it is directly correlated to the number of sensors that are present. It's negatively correlated, right? Few sensors, very high variance. The model doesn't know because there are so few sample points. So scientifically it is a conundrum, right? But I am so smart, right? I am terribly smart. I am so smart, I made this into a computer science problem for my PhD student, a privacy problem, right? So she worked, she graduated, she wrote an NDSS under Poppett's paper, and we say that, okay, there is this crypto techniques, right, where different companies will hold data, but we can still train models across them, right, using secure multi-party computation. I had very good collaborators at Microsoft Research again, and again they gave me very heavy algorithms as machine learning or crypto people give us, which is good for us, that again I have to reduce them to run it on the edge, to run it on the mobile for the clients who are asking queries, and then we have this system of privacy preserving pollution forecasting. I am not saying that because we have built this, Ola will adopt it, right? Because it will always get stuck in someone signing that this is still not safe or still not private enough. But I am just telling you that when I get stuck at a bottleneck and something is not working out, maybe there is still something that I can take out of it, which is a paper in this case. Okay? So these are, if you want to look at more at the correlation kind of stuff, where it just reports it that the complexity of factor analysis, and we are still working on the actual ML models for new RIPs this year. And the NDSS and SESAC are kind of the privacy papers which I was talking about. Yeah, so this is a kind of a tongue-in-cheek comment that I am that person that out of all this sad business around the world, I have to save my job, write papers, graduate PhD students, right? So everything which is working or not working, I am always selfishly thinking, can I write a paper out of this, right? That's what academics do, even if everything is just in shams, right? So this is a summary that budget is a problem in India, poor or costly network connectivity, we don't have it, thermal safety because we are such a hot country, government doesn't want to give permission, private companies also don't want to give permission for very different reasons, okay? And I try to find these constraints and work on these using CSE tools. So I wanted to thank Bhaskar here. I think he went for such a tennis match and he missed my talk, which is okay. So, yeah. So, I mean, most people's PhD advisors, I don't know whether they change them in such a fundamental way, right? He has changed me in a fundamental way. So, he didn't tell me that Riju, you have to get this, because I was from Jadavpur University, I did a BTech there. I had a affair with this husband here sitting now. So, I bunked most of the classes in Jadavpur, right? I didn't know things. And Bhaskar not only taught me the tools of how to write complicated programs, how to debug, even how to measure 1 meter as 1 meter, right? He was that kind of a person, and then he would give me books to read, right? He said, Riju, read Collapse, right? And let's have a chat on it. And Puru is sitting here, he is another faculty here. He would, I mean, it was like those 5 years, right, where I never had that kind of an exposure before in my life, where people were talking about sustainability, about corruption, about not copying in exams, right, because I was coming from a local regional college. So it changed certain things, and I say that, okay, if I'm 2023 now, 9 years down the line, and I'm retiring in 2049. So, like, there will be some progress, right? I mean, I will move in some direction, right? It is like the traffic, the air pollution, all these are very, very hard problems, and like, I'll keep working on it, right? And it needs some smart decision choices at every point, right? Because even an IIT Delhi CSE job is a secure place for me. They cannot throw me out whatever nonsense I try to do, right? So even getting to that position took me some random, like operating system kind of a postdoc, right, where, so that I am able to handle the selection committee. So I am telling you, I don't never advertise PhD positions. I say, if you are trying to work with me, you will get into all sorts of trouble, right? It's not a computer science PhD. But you can figure out what to do, what tools in computer science to use. Okay, and Bhaskar, Venkat, Puru, Adi Shet, they were 10 years elder to me, and they started this field in India. It's very India specific. This is a problem which we have, and a lot of you can work, but I cannot teach you the formula for it. Okay, even Bhaskar didn't it. He said, I give you some ideas, you figure out what you want to do, right? So he never like kind of spoon fed or did anything, right? Yeah, and I'll end here. So these are my other research mentors, a lot of them, and everyone taught me something. Some told me to write papers, good papers. Some taught me to work on impact. Bill Thies is an impact person. He just ditches papers all the way. CSE collaborators, a lot of them, vision people, ML people, crypto people who know the algorithms, right? And they tell me, Riju, can you run it on Indian roads, right, on small platforms? That's the problem which I solve as an engineer. And PhD students, excellent people, because they have jumped into this nonsense with me, and this non-CSE co-PIs, because it's a domain knowledge which I need, right? Sagnik is from atmospheric sciences, Geetam is from civil engineering transportation, and they write grants with me. And field partners, extremely important, government, private, startups, whoever, right? Because on the road with this work to do, I cannot be at all places at all times, okay? So I am ending at 10. I think I started a little bit late, around 9 something. So feel free to ask questions. Thank you. Yes. So, I mean, it will depend on the problem, right? So, the cameras themselves as a vision, it is affected a lot. So, Chetan, he has a PhD student, he is a vision researcher, he is working on fog, because Delhi also has a lot of fog. Fog, rain, lack of any kind of lighting conditions. So, there is a PhD who is working on, can you train on such images, like kind of data augmentation which Pratik was talking about. You take normal images, you try to add fog effect, rain effect, and then train networks to train on them. Like you know that he is trying to figure, the intuition is he is trying to figure out some constants, that the road boundaries will not jump even if there is rain, right? So he wants to find what the algorithm knows. And then based on that, he calculates that maybe there is a blurred now, because the road has blurred this much, so the car will blur this much, right? There is a lot of intelligence going on there. For my part, the embedded devices, I have to take certification, IP certification it is called. So the boxes are very well sealed. So the GPU unit, it is not, rain is not falling on that. On the bus, already there is, even without rain, they wash the bus at night. So the first few times we had issues, but now we have, I mean, there are ways to work on IP protection, what kind of boxes you should use. It goes into a little bit of material science, but the Raspberry Pi or those things are not affected, thankfully. Which are the processors? Yeah. Thank you.
Hi. Thank you for this enlightening presentation. I also struggled with the problem statement that you struggled with because I work with MSRTC during my MTech here at IITB. So my MTech was on public transportation, especially provisioning in rural areas. So I hear you that when you say budget, so essentially MSRTC has a research budget. So if you know the right people, you might end up getting that research budget. And secondly, MSRTC also has a vehicle tracking system and some small startups working in tandem with them. So in terms of, although it's yours, it includes all types of private and outside sorts of vehicles. But if you tone it down to bus transportation, you might end up getting very good data from the ground. And I mean, if you since just using sensors and everything, vehicle tracking system already uses that in MSRTC. So in fact, they track even that harsh brakes also.
Right,
If
right.
the driver is
Safety wise, yeah, sure. So this is a point that we find someone who has some resource, right? And maybe I'll catch up with him. He say, can I piggyback on you? And he asks me whether he can piggyback on me. And sometimes on funds, you can also use funds for some other thing for a project. So I got some grant from the telecommunication ministry because I was using 4G, I was sending data using 4G in my buses, right? So they said that, okay, within Delhi, what are the black spots, and can you put something on maybe highways, right, on trucks and something to know that what are the black spots of 4G connectivity along those routes. So that's money is coming from telecommunication who want to map the 4G or signal strengths across the country. And you can use that money to put pollution sensor, safety sensors, whatever you want, right? So they won't ask you that did you put anything additional, I mean the cost shouldn't go up too much, right? Because so piggybacking is always a very good.
So in case you want data, so you can connect Professor Melinda's only.
Yeah, okay, I'll connect.
He already has a GIS lab established in CS department.
Right,
so
right.
Can get, because he's under the process of another MOU with MSRTC to get their data.
Right,
Some part of their
right,
data.
right.
And that data
That,
will be
yes, it will be necessary. So all these states, we have so many states in India, right? I'm now in Delhi, I started in Kolkata and West Bengal, but every state we have to cover, right? So that picture of India which I say that when I retire in 2049, I should have a presence everywhere where we are getting more information, right? So I think Maharashtra is one of the states where I don't have a presence. So thank you very much. Yeah, thanks. Other questions, concerns?
So actually in the start of the talk you talked about the sensors for measuring the traffic. So what is the range on the width of the road which can be used, and also what is the length? Because if you want to put sensors all over the country, that will be a costly business. So
Yeah.
what is the length, width-wise and also the length-wise it can cover?
Yeah, so that is a thing that a camera sensor now, which and deep learning works well. So with a camera you can actually look pretty far, you can define whatever is interesting for you. My low cost sensors could only detect things between it. So I had to replicate the system to multiple poles. A camera will cost around, I think with all the packaging and everything, it may be around 2 lakhs or 3 lakhs when we import it. Whereas the radio sensors, even with packaging and everything, may be 500 rupees or something. But still there is a scaling cost, you are correct, right? And even maintenance wise, things might get stolen, right? And things got stolen during my PhD. So it's much more overhead, right? So that is there. In terms of the width of the road, you have to train the ML model parameters based on the width. So if it's you have trained on a narrow road, right? And now you suddenly deploy your sensors on a wide road, you will always say there is traffic jam because the signal strength will anyway drop because of the width of the road. So tuning of parameters, these days people call it transfer learning, that how do you go to a new setting, you have some model, how do you tune the parameters, right? So, but it is doable. Any other question?
Excuse me, ma'am, like if you have any CSE idea, being that third year BTech student, how you can start like in fourth year, you are very concerned about the like what to do, like placement or anything. So, how to start?
You mean BTP project? You mean in your BTP project you want to do some experiment? Is that the question?
But it is totally related to CSE, like we need to concentrate in CSE topics.
Oh, I think that's a very long chat that I mean I can talk to you over. So even I don't know, I mean a lot of BTechs in IIT Delhi work with me. So what I try to do is within this if I can define a concrete problem. For BTech it is very important. You will have 3 to 4 months, then there will be placements or something, right? So you would say know that the input will be this and the output will be this, and you build the internal building block. Don't start on very something which you don't even know like what is going on, okay? Unless you start very early. Unless from third year you are looking at the code, you know a PhD student, depends, but for BTP project, pick something where you really understand what's going on. Okay, that's one, but exactly what I don't know, who are the professors, what opportunity you have. So it's specifically for this problem where there were at least 2 companies, maybe more companies. So I am showing this car fleet here from 2 companies. That is collecting some data where the data looks like latitude, longitude, timestamp and pollution value. This company also have similar data. They don't want to share these data sets because they don't want to release this location and time because they are from their cabs. Now together, but they want to train a machine learning model. Maybe for the machine learning task is interpolation, that there is an unknown location where there is no sensor, what is the pollution value there? That is the interpolation problem. Or a forecasting problem where it says what will be the pollution there after 2 hours or 3 hours or 4 hours. So these are ML problems. ML problems need data, right? So it helps to club data across companies, but companies don't want to share their data. So the crypto part comes, the technique is called secure multi-party computation, where you encrypt, you also encrypt, so that you hold your own share. And then you can do subtraction, additions and multiplications on that data where you will know the result, but you will not know that what input had gone from the other side, okay? And even the result you can choose who gets to know it. Is it only the client? You can also try to add some differentially private noise to at the end of it so that even there is more privacy at the end of it, okay? So there are crypto blocks in each of this, and there are very strong cryptography people in India. If you want to work in cryptography, it's excellent. Arpita, MSR, and they give us somehow like very non-practical algorithms, right? Because they tend to more focus on the security side. So as a systems person, again, it will be given an algorithm, how do I actually run it in real time, right? So pollution is a real time changing phenomenon. I cannot say I will give you pollution prediction for next hour, 2 days after, right? And it changes. So I have to, and data is continuously streaming in. So I have a streaming problem where I am doing forecasting on Windows and I have to use cryptography for privacy. So how do I maintain this trade-off, right? So you can read the NDSS paper. I haven't put up the Popet's paper yet. So you can read the second paper there if you are interested in crypto, applied crypto. And if you want to build those crypto algorithms, you can go to IISc and even IIT Madras, Shweta is there. IIT Delhi also, everyone come to IIT Delhi. I am supposed to also say that because I come from there. Yeah. Right. Other questions?
Like in the frameworks you mentioned, I will say that if you're using computer vision to like speed recognition, what model are you using like, for computer vision?
Yeah, so I mean mostly it's an for speed violation detection it will be object tracking. So you will probably use YOLO or something for detecting the bounding box, and then you will try to see do a matching problem of which car was here at T2 versus now in T1, right? So you have to track objects. So we don't use segmentation because it's heavier and it's not needed. I'm not trying to color every pixel. Mostly object detection algorithms, but sometimes I have to add something before, and I don't do it, Chetan does it, for this fog, rainfall, lighting and those kind of scenarios, right? There might be derailing layers, defogging layers. right? Or maybe the network remains the same, just trained on that kind of data. Right? So whatever. Who is it? Go ahead. I don't have the data, but there are a lot of groups working on it, especially in electrical departments. We have projects in IIT Delhi also, carts and all. And of course, it's moving the pollution to a different place. In the city, we won't have emissions, so signals and everything will be fine, but that electricity is being generated somewhere. And that might be using coal or something and giving out fumes there. So we are moving the pollution problem from the city to maybe a remote area. Okay, that's the. So that's where you need these kind of people. So Sagnik, for example, is the national NCAP person. He's a IIT Delhi professor in Center of Atmospheric Sciences. So they know they are chemical engineers. Right? They know that and they can tell me that this you cannot even do. This is not computer science. But maybe you can do traffic, you can green cover, right? We can see satellite images, see what is green, what is non-green, what is built area. Lot of things computer science actually can help them with, right? And they will tell us, and you can have to talk to them and say, what help do you need, can I help?
Let's thank the speaker once again.